Alright, so in this lesson we're going to learn about inverse functions, and in the different parts of the video lessons I'm actually going to go in a slightly different order than the text. So what the text does is it gives you conditions for an inverse, tells you what an inverse is, and then teaches you how to find it. So what I'm going to do is switch the first two things. I'm going to just tell you what an inverse function is first. Then we'll talk about conditions, and then I'll teach you some methods to find them. So first we're going to look just at actually the textbook definition of an inverse. And I'm going to show you that you already know a little bit about this. Okay? So the inverse of a function, and our notation is f with a little exponent -1. I hate that notation because it looks like a negative exponent, which you might remember reciprocates. It doesn't do that. It's kind of related, but if I had my way, I would certainly change the notation. But we read that as f inverse, that f little -1. And what makes a function an inverse is it maps the points in the range of the original function f to the points in the domain of f. So what do I mean by that? Well, it's actually pretty easy to do with just a set of points. For example, if function f was equal to the points 1, 3, and 2, 7, well then that means when you plug 1 into f, you get 3 out. When you plug 2 into the function f, you get 7 out. So that would mean that its inverse, and maybe it's some other function g, but we would notate it as the inverse if it acted that way. We know for a fact it would contain the points 3, 1 and 7, 2. So what happens is the x values of f become the y values of the inverse, and the y values of f become the x values of its inverse. Now, I'm convinced you already know a little bit about this because an inverse just refers to working backwards. So if I told you to add 5 to something, how would you go backward? You would subtract 5. So for example, you could have a function f that's just x plus 5. Well, that would mean its inverse would be x minus 5. So when there's a single operation, it's kind of intuitive. You can be pretty quick in creating them. What I'm going to do though in that other video is I'm going to show you how to find more complex ones. Another example would be if you squared something, how would you work backwards? That would mean the inverse of that one would be to find the square root of it. Now, there's a little catch to this. I'm going to put a ... I'm going to show you a graph in a second about that. One more, a linear one, and just again an example to show that you might know a little bit about this already. So I'm going to say instead of x plus 5, I'm going to say what if we take a number x, we double it, and then we add 5. And that's my function. So what do you think would be the inverse? What would work backwards? Well, you'd take a number x, and you would have to work in backward order. So you would take away 5, then take all of that and divide by 2, and that would be the inverse. Let me show you a little something on a graph. We're going to head over to Desmos, and I'm going to do that one I just did. So we're going to do y equals 2x plus 5. We could do f of x notation, but we don't need to. And then the inverse was parentheses x, take away 5, close, and then divide that by 2. So there's the function, there's its inverse. There's a certain relationship that they have. Let me do that other one I just did, the x squared. Y equals x to the second. And its inverse, we said, was the square root of x. Now, for convenience, I'm going to actually do x to the 0.5 power. You might remember that an exponent of 1/2 is a square root. Now you might look, if you just kind of step back and look at this graph, you're going to see there's a pattern here. The question is, what's the pattern? What's the relationship? I'm going to graph one more line, the line y equals x. And if you look, the line y equals x goes right between all of the inverses. So what an inverse is there a reflection over that line. Let me get rid of the parabola and the square root for a second. Do you see that? So the purple original function and it's, what is that, black? Inverse, they're a reflection over y equals x. Let me turn those off, show you the parabola and the square root. So there's the parabola, there's the square root. Something's missing though, okay? Well, we're going to talk more about this in the other videos, but what we can do is we can actually restrict this. I'm not going to add on, but I'm going to take away from x squared, and I can do that on Desmos by adding a bracket and a condition. I'm going to say x greater than 0, colon, and then I'm going to close that set notation, and what I've done is I've given it a condition. Well, now you can see that the green and the black are clearly a reflection, a diagonal reflection over that line y equals x. In the next video, we're going to talk a little bit more about why we might do that, or what the conditions are, why like the whole thing didn't show up when we inverted it. And we'll learn how to find an inverse then with some algebra.